Hello everyone, welcome to Zoom in Data. In this AI 900 learning series, we will learn the fundamental concepts of artificial intelligence and explore Microsoft Azure AI services. This series is designed to help you understand the key concepts required for the AI 900 certification. Model deployment is the process of making a trained machine learning model available for applications to use. A deployed model can receive new input data and return predictions or other inference results. Deployment moves a model from the development and training environment into a usable application or production environment. Azure Machine Learning provides managed capabilities for deploying and serving machine learning models through endpoints. An endpoint provides an interface through which applications can send input data to a deployed machine learning model. The endpoint receives a request, passes the input to the deployed model, and returns the prediction or inference result. Endpoints separate the model-serving interface from the application that consumes the predictions. Azure Machine Learning supports different endpoint types for real-time and batch prediction scenarios. Online endpoints are designed for real-time inference where applications need predictions quickly after sending a request. An application sends input data to the endpoint and receives a response containing the model prediction. Online endpoints are useful for scenarios such as fraud detection, recommendation systems, customer scoring, and interactive applications. Azure Machine Learning managed online endpoints can provide scalable model serving without requiring developers to manage all the underlying infrastructure. Batch endpoints are designed for generating predictions from large amounts of data without requiring an immediate response for each request. They are useful when predictions can be processed asynchronously as a scheduled or background workload. For example, a company can use a batch endpoint to score thousands or millions of customer records overnight. Batch inference can be more appropriate than real-time serving when immediate responses are not required. Online endpoints are used when applications require immediate or near real-time predictions from individual requests. Batch endpoints are used when large datasets can be processed asynchronously and immediate responses are not required. Online inference focuses on low latency and request-based serving, while batch inference focuses on large-scale processing and throughput. Choosing the correct endpoint depends on response time requirements, data volume, application design, and operational needs. A machine learning deployment typically includes the trained model, scoring or inference code, dependencies, environment configuration, and compute resources. The model defines the learned behavior while the scoring code defines how incoming data is processed and passed to the model. The environment specifies the software packages and runtime dependencies required for inference. Compute resources provide the infrastructure needed to execute the model and respond to prediction requests. Production endpoints may need to handle different numbers of prediction requests over time. Scaling allows additional compute resources or instances to be used when demand increases. Autoscaling can help match available resources to workload requirements and avoid unnecessary infrastructure usage during periods of low demand. Deployment planning should consider latency, throughput, availability, cost, and expected traffic patterns. Machine learning models may be retrained regularly as new data becomes available or business requirements change. Different versions of a model can be registered and deployed so teams can track changes across the model lifecycle. New model versions should be evaluated before replacing an existing production version. Versioning helps support controlled updates, testing, rollback strategies, and reproducible machine learning workflows. Deployed endpoints should be protected so that only authorized applications and users can access model predictions. Authentication, authorization, network controls, and secure communication are important considerations for production model endpoints. Monitoring can track endpoint health, request volume, latency, failures, and other operational characteristics. Model monitoring can also help identify data drift or changes that may reduce prediction quality over time. Azure Machine Learning provides managed online endpoints for real-time model inference and managed batch endpoints for asynchronous scoring workloads. Models can be deployed with the required scoring code, environment, and compute configuration through Azure Machine Learning. Applications can consume deployed endpoints to obtain predictions without directly managing the model's training process. Azure Machine Learning also provides capabilities for managing deployments, scaling resources, securing endpoints, and monitoring production workloads. Model deployment makes a trained machine learning model available for real-world prediction and inference scenarios. Online endpoints are used for real-time predictions, while batch endpoints are used for large-scale asynchronous scoring. Important deployment considerations include models, scoring code, environments, compute, scaling, security, monitoring, and model versioning. For AI 900, remember that Azure Machine Learning provides managed endpoints to deploy and consume machine learning models for different inference scenarios. Thanks for watching this AI 900 learning video. For more learning content, tutorials, and real-time projects, stay connected with Zoom Data. Visit our website, subscribe to our YouTube channel, and follow us on Instagram. See you in the next video.